Okay, so we've seen for liquids that the change in volume is given by beta times the initial volume times the change in temperature, where beta is the volume expansion coefficient. Now, this works relatively well for most liquids over reasonable changes in temperatures. However, water is actually a really special case. Around 4 degrees C, water stops obeying this rule. So above 4 degrees C, as we heat water up, it expands and becomes less dense as we would expect. So you've probably experienced this on a warm day. If you're the first person to jump into a swimming pool on a warm day, you've probably noticed that the top layer of the water is warmer than the layers below. As you dive down, it gets colder. The reason for this is that the atmosphere is heating up the top of the pool. As that water is heated up, it expands and becomes less dense. Less dense things float on more dense things, and so we get a nice warm layer of water at the top of the pool. Now, below 4 degrees C, water is actually really special. It becomes less dense as it's cooled down. So this actually has some really lucky consequences for fish. So let's now consider a cold winter's day, say in the snowy mountains or somewhere where the temperature is at, say, 2 degrees C, and consider a pond. Now, the atmosphere is colder than the pond. We'll have our pond at 4 degrees C to start with, and so it's removing heat from the pond, and so the top layer of water on the pond drops down to be in thermal equilibrium with the atmosphere at, say, 2 degrees C. Now, in this case, because it's lost some of that heat and become colder, it's now less dense than the water below it at 4 degrees C, and so in this case we actually get a cold layer of ice forming on the top of the pond, which acts as an insulator because ice actually loses heat less quickly than water. And so this stops the rest of the pond cooling down so quickly, which is why before I said it was lucky for fish, because this means that we can get to lower temperatures for longer times and still have a layer of water down the bottom of the pond. Okay, but remember, water's a special example. This doesn't happen for most liquids. For most liquids, as we heat them up, they do expand over reasonable temperature changes.